Hi friends, hope you're all doing fine. So welcome back. Let's continue our discussion on producer behavior. Now we are moving to an important step. Okay. See, we discussed about consumers equilibrium. That is when a consumer will be satisfied. When will a producer be satisfied? I told you in consumer discussion that a consumer will be satisfied when he gets maximum satisfaction for the price he is paying for it. So, what about the producer? The producer will be satisfied only if he is made to think or he feels that he has maximized his profit. Okay, it is not with reference to the cost or anything. Maximized his profit. So, what is profit? First of all, we are going to see a few basic points. Okay, profit. What will be profit? Amount gained minus amount spent. TR minus TC. Total revenue minus total cost. This should be maximum. When will this be maximum? Think of it. When will this be maximum? You know the behavior of revenue and you know the behavior of cost. And we know two forms of market. When will this be maximum? See, TR is equal to quantity into price. Okay. And TC is equal to quantity into cost. Okay. So leave it all this. When will this be maximum? We can either use the average method or we can use the marginal method. But generally we use the marginal method. Okay. So when will this be maximum? When we are taking the derivative of these two things, TR minus TC, this function's derivative with reference to the quantity, we will get delta TR by delta Q minus of delta TC by delta Q is equal to 0. This is how we derive. What will this be? That is delta TR by delta Q is equal to delta TC by delta Q. Right. We are just changing. We are solving the equation. What is delta TR by delta Q and delta TC by delta Q? This is equal to MR is equal to MC. So this is how we are deriving equilibrium. Okay, there is the principle of maximization which we are using here. So TR minus TC will be maximum if and only if MR is equal to MC. Now let's see. Just MR is equal to MC. Does it mean profit will be maximum? We'll have to know that, right? So, condition for equilibrium. Okay, the first condition is MR is equal to MC. Okay, first condition is MR is equal to MC. But does it mean that profit will be maximum if MR equal to MC? Let me give you an example. MR is equal to MC means the curves will cut each other. Let's take an example of perfect competition. Alright, because this is the simplest example. In perfect competition, what will happen is X, O and Y, quantity and price or price variable. Okay, now in perfect competition, MR will be equal to AR. Okay, So this is MR curve. MR. So what about MC? MC will initially decrease and then it will increase. Now see the problem. It is cutting the AR curve or the MR curve in 2 points. Where do we get the equilibrium point? This is what we are going to discuss. See, if the producer is here, okay, say is producing something O1 level of output. Now, what will be the profit gained by the producer? Definitely, the producer will have no profit. Why? Why? Because MC is so far greater than MR. So what will happen? The producer is continually increasing or incurring losses. So what will the producer see? What? I have to produce this much when I am keeping on increasing losses. Better than that, I will just cut down my production. I will never produce anything. At least I will incur only the loss of fixed cost. I will at least not incur the loss of variable cost. Because variable costs are the ones that lead to MR. Okay, so what about here? Now see, let's say producer is producing this much level of output. Okay, here MR is here and AR is here. Okay, means MC is less than MR. Now the producer will ask you, sir, do I have any opportunity to increase my profit if I produce more? I am happy because I am earning some profit. At least in the last few units, I am getting more revenue than the additional cost which I am spending. So, will I have any opportunity to increase profits further? Now we are saying, yes sir, you can increase your profit because still here MR is greater than MC. So this is also not point of equilibrium because the producer has further possibility to increase his profit. Now this point, what about here? At this level or O3 level of output, what will happen? Here MR is equal to MC. So there is nothing, the first condition is satisfied. Okay, nothing in that. Now consider if the producer needs to produce more. Let's say if producer wants to produce O4 level of output. Beyond here, MC will be greater than MR. So what will happen? Naturally, the producer will start reducing profit. For each additional unit he is producing, the producer will get losses. Okay, so what will happen? So therefore, the producer will not operate there. This is the only point where the producer will be willing to operate because MR is equal to MC and the maximum level of profit is obtained at this point. So, now, if you ask me, there is another way we can express equilibrium in case of producer. I told you equilibrium is where the producer is maximizing profit, or equilibrium is where the producer has no other way or no possibility of increasing profits further. Beyond this point, the producer has no possibility to increase profit. At that point, the producer will be at equilibrium. So what will happen? We are telling that I told you MR output, MR MC. Okay, here I told you at this point the producer will be at equilibrium. What is the speciality of this point? MR is equal to MC. We don't want to tell. But the slope of MC curve will be greater than the slope of MR curve. Right? Think of it. MC is positively sloped and MR is here, it is not sloping, it is zero slope because it is a straight line parallel to x-axis. Therefore, to generally slope of MC greater than slope of MR. Why? This is the only point of equilibrium. Now, let us state the equilibrium condition for perfect competition and imperfect competition. Condition under perfect competition. In perfect competition, what will happen? Our same earlier diagram, there is no change, but just to state the condition, I am just drawing output MR MC. This will be parallel to x-axis MR and MC, and this is the point of equilibrium. Here what will happen? The first condition is MR is equal to MC, right? Second condition is MC cuts MR from below. MC cuts MR from below. This is the second condition for equilibrium. Now let us discuss the case of imperfect competition. Imperfect competition. What will happen in imperfect competition? X, O and Y. Output MR, MC. In imperfect competition, what will be the shape of MR? MR will definitely be downward sloping. MR. And MC, there is no change. Whatever be the form of market, MC will behave as it is. Whatever you do, whatever you may do, MC will never change its behavior, and therefore MC will keep on going like this. MC. Now say the cutting here and here, 2 points. Here definitely the producer is incurring losses, because MC will come from up. So here the producer will incur losses. Now if the producer is producing anywhere between here and here, the producer will have the possibility to increase profits further. I have already told you the scenario in case of perfect competition. Consider this point. Okay. Here what will happen is MR is only this much and MC is this much. The producer who was once earning profit has started to lose on his profit. So the producer will not operate there. This point is the point of equilibrium. Okay, we cannot say definitely MC is cutting MR from below. However, MC is mildly positively slow. MR is negatively slow. Therefore, the first condition we know MR is equal to MC. Second condition, MC is positively sloped, MR is negatively sloped. Therefore, slope of MC greater than slope of MR. Okay, this is why I told you this, because whatever we take the form of market, this is the general condition of equilibrium. Though in perfect competition it's a special situation and we are stating the equilibrium condition in another form. But general equilibrium condition, MR is equal to MC. 1. Necessary but not sufficient. It is needed, but MC equal to MR alone doesn't guarantee equilibrium. Then the second condition is slope of MC curve greater than slope of MR curve. Okay. Let's take an example. I'm not going to draw a figure because whenever you get an exam, if you have to draw the figure each time, it will be a bit boring. So let's take output MR, MC. And generally I will discuss in the case of imperfect competition. In perfect competition, you know, because MR will be always constant, and therefore when MC is going down, we will not take the equilibrium. When MC is increasing, we will be taking equilibrium. Let's take 1, 2, 3, 4, 5 units of output. And let's say the MR is rupees 20, 18, 15, 11, 6. This is how MR curve. This is MR. What will happen to MC? MC is initially 25, 22, 15, and let's say the MC then becomes 4 and then again 6. Okay. Here there are 2 points where MR is equal to MC. 1 and 2. Here when you see MR curve is always negatively sloped, you did not see that. What about MC curve? MC is also negatively sloped, right? Because MC is coming down. Here, forget about the slope of MR. MR will always be negatively sloped. But think the case of MC curve. MC curve has increased from 4 to 6. Therefore, at output level of 5, units, producer attains equilibrium. Why? Because both the conditions necessary for equilibrium are fulfilled only at 0.6, never till at 0.3. Because here the second condition, slope of MR less than slope of MC, or slope of MC greater than slope of MR is violated. So this is all for this session. Now just revising, we know what is MR MC approach. When the producer attains equilibrium, that is when he or she attains maximum profit, or it is not possible for the producer to further maximize his profit. Under perfect competition, the condition for equilibrium are first MR is equal to MC, and second MC curve cuts MR curve from below. Under imperfect competition, the same first condition MR is equal to MC, but the second condition is the general principle slope of MC greater than slope of MR. So this is all for this session. However, we have one more topic under producer behavior. We will discuss that in the next session. So till then, thank you. Goodbye.